Hi, my name is Tom and you are at level 33 in Mastering Einstein Special Relativity. This is the C level where we will do the actual calculations to see how we can fit a big rocket in a small shed and even take a picture of it. I'm assuming you've seen levels A and B, but I will do a short recap. First, we know that fast moving objects shrink. Classic length contraction, level 28. We also learned in level 32 that when we videotape stuff, things change. Stuff approaching us seems to be bigger, faster and further away than it actually is. Stuff moving away from us appears to be smaller, slower and closer than they actually are. So what will we see if we take a videotape of the big rocket moving in the small shed? So what's the experiment? We have a 25-meter rocket and a 20-meter shed, and we will fly the rocket in the shed and then it will leave the shed again, and because it's moving so fast, its length will contract down to 15 meters instead of 25. 15 meters fits 20 meters, so we will be able to take the picture of the rocket in the shed and then it can move on. This is what we will do. And in the previous levels we talked about this, so I'm now just going to show you all the animations at once. Top row, the farmer's world. What actually happens on the left and what the videotape told him on the right. Bottom row, what actually happened on the left for the rocket's perspective and what the videotape looked like on the right. I'm not going to talk a lot about this because I did in the B and the A level. So let's look at the animations. And here you see that we have 4 different realities. I mean, sizes are different, velocities are different, the moments when doors are being opened and closed is different, simultaneity has gone out of the window. I mean, this is 4 realities and, you know, of course people will want to know what's true. Well, both of them on the left are true. That's what's really happening, but we are just not able to capture that on video. As soon as you start videotaping, you will run into the tapes on the right and they will not tell you what actually happened. They will be deceiving you. So this is what happened. And now we are going to do the actual numbers. Let's see. First, without the video, just classic special relativity. Here we have, I've used it before, my event table. We have 13 events, there they are in gray. And in red we have the reality from the farmer's perspective, the shed. And in blue, the rocket's perspective. And what I did is I put in all the stuff we already know. The X, the location of those events, and the time of the events. And in this case I've chosen to put C times time instead of X over C. If you watch the clip on the space-time diagram, you know that you can either go for X over C versus T or X versus CT, and I've chosen X versus CT here. So location and time for the events 1 through 13 in the red. The farmer, its location will always be 0. He defines the origin of his frame of reference. So anytime he will be at 0. The back of the rocket. Well, the back of the rocket is moving at 80% of the speed of light. So we have 0.8 times C times the time on the clock, the observer 1 clock. So the time of an event, in this case event number 2, from the perspective of observer 1. Minus half of the contracted length because it has been contracted. That's the X coordinate of the back of the rocket, and the front of the rocket will be the same, but instead of minus we do plus half of the contracted length. This should be, this should not puzzle you, right? This should be clear. The E should have been E2 and E3, but you know, it's any time, so that's why I probably did not put the 2 and the 3 in there. Then event number 4, RF, which is the front of the rocket, enters the shed at the left door. If you do the math, then you will see that will be at -10. Why? The shed is 20 meters long. The origin of the rest frame is in the middle of the shed. So the left door is at -10 meters. E5 is also, again, the left door is also at -10. What about the timestamps of event 4 and 5? Well, these can be calculated when they are being shut. Enters. No, oh no. I'm way ahead. That's why I was hesitant. This is when does the front of the rocket RF enters the shed. Well, if you just put it on paper and you know the velocity and where the rocket started, in this case it will be at -21.875, and the back of the rocket will enter the shed at -3.125. This is just a given, right? Then the door close at -2, also arbitrary. Well, not completely arbitrary. I had to wait for the rocket to be entirely inside the shed, and apparently that was at -2 point something, I guess. So at -2 seconds I closed the doors. Of course, the position of the doors is still 10 meters for the right door, -10 for the left door. The center, event number 8, the rocket and the shed are centered. Their frame of references aligned. That's 0, 0. We take the picture at that same moment, 0, 0. And then some symmetry is going on. The doors now open. Which doors? Well, the ones at 10 and -10 meters. Now at +2 seconds. Also arbitrary, but I had to open the doors before the front of the rocket hits the second door. So that was 2 seconds. I picked 2. And then the rocket leaves the shed, the front first, and then the back leaves at those seconds. So this is in the red. This is what we know and shouldn't be that complicated. So what do we know from the rocket's perspective? Well, the rocket will say, you know, the farmer is always -0.8 times C times my time, you know, away from me. We go to event number 2, the back of the rocket. Well, from the rocket's perspective, his center of origin is in the middle of the rocket. So the rocket is 25 meters long, so the back of the rocket is -12.5 and the front of the rocket is +12.5. So that's what we see at event number 3 and 4. This is all the time. When the front of the rocket enters the shed, well, from the rocket's perspective, the back and the front of the rocket are always the same. So we can put in again 12.5, -12.5. Some of the stuff I did not put in because we have to actually calculate it. We don't know events number 8 and 9. Also, the rocket and the shed align. Their clocks are synced at that moment. So location and time is 0, 0 for event number 8 and also 0, 0 for event number 9. And the last 2 events, events number 12 and 13, again 12.5, -12.5, because the doors didn't go anywhere from the rocket's perspective. So I think this table is right. Cool. So that's it. How can we calculate the cells that are empty? Et voilà. Of course, using the Lorentz transformation. Here it is. And here are the notation rules. You should now be able to dream them because I've talked about them, I think, in at least 10 or maybe 15 levels. So you can actually read what the equations are. And if you apply the Lorentz transformation for event number 6, event number 4, 5, 6, 7, and 10 and 11, you get these numbers. You could have paused the video and tried it yourself, but you will get these numbers. So now you know what really happened in the world for the farmer, and what really happened in the world of the rocket. Now we will add in the video camera. Are you ready? This is a lot. And I'm not asking you to watch me talk about these numbers for a few hours. I'm not going to do that. You can pause the video and see if you can understand what's going on here. I do have some legends here. So the properties: W is width, V is velocity, X is location, T is time. Then we have the indices. S will be shed or stationary. The D will be for the door. R will be for the rocket. And sometimes we will use the actual events in the previous list. Events number 6, 7, 10 and 11. When doors are closed and opened again. Perspectives, S, so comma, a perspective, stationary or the shed's perspective. S vid will be what's on the video, so the farmer's video perspective. R will be the rocket's perspective, and R vid will be the video of the rocket. And there you see that in the red, the farmer's truth is different than what he sees on the video. Of course, the width of the shed will be 20 on the video and the actual world. The shed will not be moving, second row for the farmer in the video and in reality. The doors will have a length of 14.5 meters. It's just, I picked those arbitrarily. I just wanted to have 14.5 meter doors. So that's what they are. But when you look at the rocket length, then you have to add in length contraction by dividing by the Lorentz factor gamma to get to the rocket length in the red. And if you want to know what's on the video, then you have to correct the contracted length again by dividing by 1 minus V or 1 plus V, depending on if it's coming or going. For the rocket speed also, you have to divide by 1 minus V or 1 plus V. This is level 32, right? I'm just repeating level 32. We did all the derivations of these equations, so you can just go there. Then the last 4 rows are about opening and closing, closing and opening the doors. We know in the red when it happens for the farmer, the actual happens, and that's by choice. I picked minus 2 seconds and plus 2 seconds. The doors are always at 10 and minus 10. And then you can see what it is on the video. And on the video, you need to take the same timestamp as the actual timestamp and then add the number of seconds you have to wait for the light to travel from the object, in this case the shed, to the camera. And that's an absolute, so that's why the absolutes are there. And you can do the math, and then you will find that it's you can find the numbers in the orange column. Then the blue one, the dark blue, is the one that we already did in the previous table, right? This is the actual truth. And then again, if you go from truth to video truth, you have to divide sometimes by 1 minus V, sometimes by 1 plus V. And that's what we're doing here. And if you want to know the last 4 events, it's easier to just use the Lorentz transformation for the dark blue column, and then use common logic, I would say, for the light blue column. Again, you take the timestamp of the original event and then add the time it needs to take to travel to your camera. And that's what we did with the absolute thingies here. And here you have it. Here are all the numbers. And if you go back and check my animations and disregard that I did not sync farmer and rocket due to time dilation, when I play the animations side by side. But if you look at the animations individually, you will see these numbers. You can see on the clock, I see the door close. I see the door open at that location, there and there. These are the numbers. I think this is it. Is this it? Yes, this is it. So, I want to thank you again for watching the C level, the one which is the toughest. Using all the equations, getting the numbers right, but here it is. There's more, of course. I always end my videos with the full story. 18 levels, and then from level 19 all the way up to 34. Just one level to go. Because putting a big rocket in a small shed is the second best known example of special relativity. But the number one example in special relativity, of course, is... No, it's not GPS. Also famous. It's the twin paradox. I have to do the twin paradox. Although there are probably hundreds of videos out there doing this. And I will try to make it more entertaining, more in-depth, and a little bit more different, I would say, to close that one off. And I will be adding the real world perspective again, the videotaping of the twin paradox, and that's something I haven't seen done before. Thank you for watching, and I hope to see you at the next level.